Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for the function f of x equals x squared plus 64 divided by x cubed plus 4x squared minus 16x minus 64. The first thing to find is the y-intercept, where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate can be found by plugging the 0 in 4x into the function f of 0, which is 0 squared plus 64 divided by 0 cubed plus 4 times 0 squared minus 16 times 0 minus 64. 0 squared is 0 plus 64 divided by 0 cubed is 0. 4 times 0 squared is 0. Minus 16 times 0 is minus 0. And then minus 64. 0 plus 64 is 64. 0 plus 0 minus 0 minus 64 is a negative 64. The 64's can cancel, giving 1 over negative 1, which is negative 1. The x-coordinate was a 0. The corresponding y-coordinate was found to be a negative 1, and there's the y-intercept. The other parts are found by taking the function f of x, which is x squared plus 64 divided by x cubed plus 4x squared minus 16x minus 64. And fully factoring the numerator and denominator, the numerator is a sum of squares, does not further factor. The denominator is a 4-term cubic, and so may factor by group factoring. Group together the x cubed and the 4x squared. Group together the negative 16x and the negative 64. The first two terms, x cubed plus 4x squared, have a common factor of x squared. Factoring that out leaves behind an x plus 4. A negative 16x minus 64 has a common factor of negative 16. Factoring that out will leave behind also an x plus 4, so it does group factor since the x plus 4s match. And now the x plus 4s can factor out, leaving behind an x squared and a minus 16, which itself is a difference of squares, and so further factors, we have an x plus 4, and then the factorization of x squared minus 16 will be x plus 4, x minus 4. The x plus 4s can be put together to give x plus 4 squared times x minus 4. We now want to cancel out any common factors in the numerator and denominator. There are no common factors. The next thing to find is the x-intercepts, where the function crosses the x-axis, corresponding to and defined by y equals 0. These are found by taking the numerator in the fully factored cancel version of the function and setting it equal to 0. X squared plus 64 equals 0. Subtract 64 from both sides. X squared equals to negative 64. Take the square root of both sides, which gives a plus or minus square root of the negative 64. A square root of a negative number is not a real number, and therefore there are none. The vertical asymptotes are found by taking the denominator in the fully factored cancel version of the function and setting it equal to 0. So x plus 4 squared times x minus 4, set equal to 0. Solving for x will give x equals to negative 4, and x equals to positive 4. We want to analyze the asymptotic behavior on each side for each of these vertical asymptotes. Starting with the x equals negative 4 vertical asymptote, we can look at the left-sided limit of the fully factored canceled version of the function. And the right-sided limit also of the fully factored canceled version of the function. Let's start with the left-sided limit. The left side of negative 4 is more negative than negative 4, like negative 4.01. If that were plugged in for the x in the factor that's making 0 in the denominator, that would be the x plus 4 factor here, since x is approaching negative 4. If plugged in for the x there, negative 4.01 plus 4 is a negative number. It will approach 0, but it will remain negative, so we can replace x plus 4 with a negative 0. Negative 4 can then plug in for all remaining x's. So x plus 4 will be a negative 0 squared, and negative 4 plugged in for all remaining x's. In the numerator, negative 4 squared is a 16 plus a 64. In the denominator, negative squared is a positive, 0 squared is a 0. Negative 4 minus 4 is a minus 8. 16 plus 64 is an 80 over positive times negative is negative, 0 times 8 is 0. The 80 in the numerator is a positive. Positive over negative is negative. Non-zero over 0 is an infinity. The right-sided limit can be analyzed in a similar fashion, but where the right side of negative 4, which is less negative than negative 4, like negative 3.99, when plugged in for x in the factor that's making 0 in the denominator, negative 3.99 plus 4 is a positive, and x plus 4 can be replaced with a positive 0. Negative 4 can plug in for all remaining x's. Negative 4 squared is 16 plus 64, divided by positive squared is positive, 0 squared is 0, minus 4 is negative 8. 16 plus 64 is an 80. Positive times negative is negative. 0 times 8 is 0. The 80 in the numerator is a positive. Positive over negative is negative. Non-zero over 0 is an infinity. And the asymptotic behavior on each side turn out to be the same. They both go to negative infinity. We can analyze in a similar fashion the left side and right side of the x equals 4 vertical asymptote. So we have the left side limit and the right sided limit. Let's start with the left-sided limit. We want to look at the left side of 4, which is less positive than 4, like 3.99. When plugged in for the x that's making 0 in the denominator, that's the x minus 4 here. 3.99 minus 4 is a negative number. It will approach the 0, but it will remain negative, so we can replace that with a negative 0. 4 can plug in for all remaining x's, giving 4 squared plus 64 divided by 4 plus 4 squared, and times what will be a negative 0. 4 squared is 16 plus 64 divided by 4 plus 4, which is 8 squared, times a negative 0. 16 plus 64 is an 80 divided by 64 times a negative 0, which is an 80 over positive times negative is negative, 64 times 0 is 0. That 80 in the numerator is positive. Positive over negative is negative. Non-zero over 0 is infinity. The right side limit can be worked in a similar fashion. The right side of 4 is more positive than 4, like 4.01. If that were plugged into the factor in the denominator, it's making 0. 4.01 minus 4 is a positive number. It will approach to 0, but it'll remain positive. So we can replace x minus 4 with a positive 0. 4 can now plug in for all remaining x's. Four squared is 16. So 64 over 4 plus 4 is 8 squared times a positive 0. 16 plus 64 is 80 over 8 squared is 64 times a positive 0. So we have 80 over a positive times positive is positive. 64 times 0 is 0. That 80 in the numerator is positive. Positive over positive is positive. Non-zero over 0 is infinity. And the asymptotic behavior on each side for the x equals 4 vertical asymptote are opposite of each other. One's negative infinity, the other one's positive infinity. The last thing to find are any holes in the graph, and the holes occur in the factored version for any factors that fully cancel out into the denominator, but we did not have any factors cancel for the factored version here, which means there are none.